Hello, and welcome to G Fun Facts Online, where we get curious about the science that shapes our world. You've probably heard the saying, "Don't reinvent the wheel." It's a classic phrase we use to describe putting effort into something that's already been solved. But what if I told you that some of the brightest minds in engineering are doing exactly that? They are reinventing the wheel, and for very, very good reasons. For over a century, the air-filled pneumatic tire has been the undisputed king of the road. But it has a critical weakness: the air inside it. Imagine a world without the dread of a flat tire, a world without the hassle of pressure checks, and most importantly, a world without the danger of a sudden high-speed blowout. This isn't science fiction. This is the promise of airless tires, a technology that's rapidly moving from the lab to our roads, and it's poised to completely redefine our relationship with driving. So today, let's explore this incredible innovation. Why are we reinventing the wheel, and what will it mean for all of us? Let's start with the basics. Why bother changing something that has worked for so long? The problem is what we call the pneumatic predicament. Our traditional air-filled tires are vulnerable. A single nail, a piece of glass, or a nasty pothole can leave you stranded on the side of the road. Even worse is a blowout, a sudden, catastrophic loss of pressure that contributes to thousands of accidents every year. Beyond these dramatic failures, there's the constant, low-level hassle. You have to check your tire pressure regularly. If it's too low or too high, you get worse fuel economy, your tires wear out faster, and your car just doesn't handle as well. And when they do wear out, disposing of old tires is a massive environmental headache. These are the problems that have sent engineers on a quest for something better, something more robust, reliable, and sustainable. So how do you make a tire without air? The fundamental idea behind airless tires, or non-pneumatic tires, is to replace that cushion of air with a cleverly designed physical structure. Instead of air holding up your car, these tires use a network of flexible, high-strength spokes, or a honeycomb-like matrix. This structure is engineered to do two things: support the weight of the vehicle and deform to absorb bumps, just like an air-filled tire. When you drive over a bump, the spokes or cellular structure flexes and bends, providing that crucial cushioning effect. These internal supports are made from advanced materials, usually high-strength polymers, that can bend and snap back into shape millions of times without breaking or wearing out. The outer part, the tread that actually grips the road, is often made from similar rubber compounds to the ones we use today. A great example is Michelin's Tweel, which is actually a combination of a tire and a wheel in one unit. It has a solid central hub, flexible polyurethane spokes that support the weight, and an outer tread. The spokes are the magic here, flexing and absorbing impacts to keep the ride smooth. Now you might think this is a brand new idea, but the concept has been around for a while. Way back in 1938, an inventor named J.V. Martin created an airless safety tire with hickory wood hoops and crisscross spokes. But the real push came from an unlikely place: outer space. For the Apollo moon missions, NASA needed wheels for their lunar roving vehicle that couldn't go flat. The solution? A non-pneumatic wheel made of woven metal mesh. It proved that the concept could work, even in the most extreme environments. In the last couple of decades, major companies like Michelin, Goodyear, and Bridgestone have poured money into research, bringing us the advanced prototypes we see today. The key to all of this progress is materials science. You need something that's incredibly strong, but also flexible. It needs to be durable, but also lightweight. And increasingly, it needs to be sustainable. The star players are polymers and composites, like thermoplastic polyurethanes, which have amazing flexibility and wear resistance. The tread is still made of specialized rubber for grip, and the central hub is usually strong, rigid aluminum. NASA is even experimenting with shape memory alloys, metals that can be bent and deformed and then return perfectly to their original shape, offering incredible durability. So, what are the big advantages? Why is this technology gaining so much traction? The number one benefit is immunity to punctures and blowouts. Airless tires simply cannot go flat. This is a massive leap forward in safety and convenience. No more spare tires, no more jacks, no more waiting for a tow truck. This also means less maintenance. Forget checking your air pressure. For commercial fleets, like delivery trucks, this is huge, because any downtime costs money. These tires are also designed to be incredibly durable, potentially lasting 2 to 3 times longer than conventional tires. This leads to a huge environmental benefit. Michelin estimates that if their airless tire, the UPTIS, was widely adopted, it could prevent up to 200 million tires from being scrapped prematurely every single year. Of course, if it all sounds too good to be true, you're right to be skeptical. There are still some significant hurdles to overcome before we all have airless tires on our family cars. The biggest challenge is ride comfort and noise. Air is a fantastic vibration dampener. It's hard to replicate that cushioning effect with a solid structure. Early prototypes were often criticized for feeling stiff and being much louder than normal tires. Another issue is heat. Tires get very hot, especially at high speeds. The complex structures of airless tires can trap heat more easily than pneumatic ones, which can affect the durability of the materials. Then there's the cost. Advanced materials and complex manufacturing mean that, for now, airless tires are more expensive to produce. And finally, there's the slightly strange problem of debris. The open-spoke designs can get clogged with mud, snow, or rocks, which could throw off the tire's balance. Despite these challenges, the progress is undeniable. Companies like Michelin, with its UPTIS prototype developed with General Motors, and Goodyear, which has tested its airless tires on Teslas at speeds up to 160 kilometers per hour, are leading the charge. Bridgestone and Hankook are also developing their own unique and often recyclable designs. So where can you find them now? While they aren't common on passenger cars just yet, airless tires are already a reality in many areas. You can find them on golf carts, ATVs, lawnmowers, and heavy industrial equipment like forklifts, where preventing flats is the top priority. They've even been tested on DHL delivery vans in Singapore, proving their worth in commercial logistics. The future for airless tires looks incredibly bright, especially when you consider the other major shifts happening in the automotive world, electric and autonomous vehicles. For EVs, the consistent performance and potentially lower rolling resistance of airless tires could help increase battery range. For self-driving cars, reliability is everything. An autonomous taxi that can't get a flat tire is a huge operational and safety advantage. As the technology matures, expect to see new materials and designs that improve ride comfort and reduce weight and cost. We may even see smart airless tires with integrated sensors that provide real-time data on their condition. Ultimately, reinventing the wheel is a monumental task. But the science and engineering behind airless tire technology are steadily paving the way for a future where the flat tire is a relic of the past. The journey is far from over, but the destination, a world of safer, more convenient, and more sustainable driving, is well worth the effort. Thanks for joining us on Fun Facts Online. We'll see you next time.